All right, this is module 36, Use Proportionality theorems. In this particular module, there are going to be a few other theorems that are going to be associated with triangles and similarity. Our first one is called the triangle proportionality theorem. And it states, if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. Which means that you can say that if TU is parallel to QS, then RT is going to be equivalent or in ratio with TQ's length. RU is going to be in ratio with US's length. The other thing to think about as well, because this isn't the only ratio or proportion that can be made, you can also have RQ's length to, like, let's say RT's length. That should be the same, or could be the same as the long length of the other triangle, which would be RS's length, is to RU's length. So there's many proportions that can actually be created here. This is just one, but this occurs when the two lines here are parallel. And in a later module, you'll actually see that this is an important theorem as well. So, converse of triangle proportionality theorem. So, if a line divides two sides of a triangle proportionally, then it's going to be parallel to the third side. So, it's basically taking this and saying, okay, well, how do we know that the triangle has these two parallel lines? Well, if we take the values of RT divided by TQ, and say they're equal to RU is divided by US, and we actually find out that those two ratios are equal, or the proportions is equal, then we can state that the two lines are going to be parallel because the proportion is true. Okay, so here, good question. In the diagram, I tell you that QS is parallel to UT. I also tell you that RS is 4, ST is 6, QU is 9, and I ask you what the length of RQ is. So, a bunch of different ways you can do this. Here is one way. So we can say that RQ is to QU as RS is to ST. So, when you do this, you plug in your values that you know, and your unknowns you keep as an unknowns. RQ we do not know, but we know QU is 9, RS is 4, ST is 6 from the diagram. After this, we cross multiply. You can make your peanuts. Cross multiply, and you get RQ is equal to 6. So once we find the length, we're done. Okay. In this, as I'm sure everybody has a shoe rack that hopefully they did not build. In this case, it says, on the shoe rack shown, AB is 33 centimeters, BC is 27 centimeters, CD is 44 centimeters, and DE is 25 centimeters. Explain why the gray shelf is not parallel to the floor. So, why? You set up a proportion. You can see? And don't just say because it visually looks it. No, you have to find and simplify the ratio of the lengths determined by the shoe rack. So, I do CD is to DE which is 44 is to 25, and then I do CB is to BA, which is 27 is to 33. Since these two are not equal, BD is not parallel to AE, so the shelf is not parallel to the floor. So this might have been something that was built by Homer Simpson, because it's not perfectly parallel. That's a joke from the 90s, if you don't get it. Okay, so we have transversal theorem. If three parallel lines intersect two transversals, so remember in a previous module we had two parallel lines cut by a transversal. Well, in this case, it's three parallel lines intersect two transversals, then it's going to divide the transversals proportionally. So many different things that can actually be created here. UW to WY, we have VX to XZ. The other thing is, if I took this entire thing here and I extended these two lines, this line here, until they intersect, then you're going to have a triangle. You're going to have actually one triangle, a middle triangle, and then a third larger triangle. So all the other theorems that we had are going to be evident as well. So this is one of my favorite theorems here, the opposite side theorem. And the reason is because I think it's really easy to do, and there's a real cool mnemonic device to learn how to do it. So it says, if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So what does that mean? You can say that AD is to DB as CA is to CB. Now the cool thing is, the reason I say this is my favorite is because this is one way of putting the proportion. The other way of putting the proportion is you start off at the vertex C, and you go along C, A, and then to AD. So CA is to AD is the same as, and you start at C and go along the other side. So CB is to DB. So CD is to DB. So this is another proportion that can be created as well. And the reason why this is evident or is the same is because all you're doing is you're doing the interchangeable and the reciprocal property in this. So it's still the exact same thing. You'll get the exact same answer, and you'll see why in the next slide, or in the next couple slides. Okay, so we have in the diagram angle 1, angle 2, and angle 3 are all congruent, and GF is equal to 120 yards. DE is equal to 150 yards, and CD is equal to 300 yards. Find the distance HF between Main Street and South Main Street. So what I'm going to do is I'm going to set up, again, a proportion, because I know I have 3 lines that are parallel. The reason I know that is because of corresponding angles. 1, 2, 3. Those corresponding angles are all congruent. That means that these lines all have to be parallel. Okay? So I can set up my proportion of HG is to GF and CD is to DE. Once I do that, I plug in what I know. What I'm going to do here, this is actually called the addition property. I'm taking the numerator, the denominator, and adding it to the top. I can do the exact same thing over here. But if you don't like that, you don't have to do that. That's fine. You can still come up with the same exact answer. You're just going to have to do one more step. So, and you'll see what I mean in a second. So when I do this, HG, I plug in the values that I know. HG plus GF is the entire length of HF. So when I do that, GF is 120. CD's length plus DE's length, again, this is segment addition postulate. You get 300 plus 150. That gives you 450 total. Cross multiply and you solve, and you get HF is equal to 360. Now, if that made absolutely no sense to you, because I did go through that kind of quickly, just use this, if that one makes sense to you, because that's straight from the theorem. And just plug in the values, and you get HG, we don't know, is X. GF is 120 degrees, or 120 length. CD is 300. And then we know that DE's length is 150. When you cross multiply and solve, you will actually get 240. So X is equal to 240. Problem is that's this guy here. That's HG's length. So we don't want HG's length. We actually want the distance between Main Street and South Main Street. So we have Main Street and South Main Street is this distance here, which is HF's entire length. That's why this, adding the denominator to the top of both of the ratios, is a shortcut. But again, if you don't understand that, what you're going to have to do is going to say, okay, well, I know that 240 is HG. That's 240. I have to add GF to get the entire length, which we know GF is 120, and you still get 360 here, the entire length. So whatever way makes sense to you, this is where the creativity comes in mathematics. Okay, so the next one in the diagram, angle QPR is congruent to angle RPS. So we know they're congruent, so that means it's going to cut the sides proportionally. use the given side lengths to find the length of RS. I'm going to do this my specific way, the one that I thought was the quote-unquote easier way. If we know the entire length here is 15, we know just this little part here is x, we can state that this part here is 15 minus your x, your total length minus the length of RS. So if we know that, then we can set up my little hook method that I said. So 7 is to 15 minus x is equivalent to 13 is to x. And call that the hook method. So you can cross multiply and solve. Again, the other way of doing it, if you want to just plug it into the straight one, which is the one that I used in the actual theorem, which would be 15 minus x is to x, which equals 7 is to 3. Cross multiply and solve, you're still going to get the exact same answer of 9.75. Okay, so these two are equivalent. I think this one here is easier because it involves the hook method. So if you can remember it as the hook method, you should be good to go.